Hello everyone. So in today's session we will be continuing with our probability, and the topic that we will be dealing with today is independent events. Now let us first understand what is independent event. So I am going to give an example. Let us consider the random experiment be rolling of 2 die. So here rolling 2 die. Let A be the event of getting 6 on the first die, and B be the event of getting 6 on the second die. Now, when you roll 2 die, does it anyhow affect the occurrence of 6 on the first die and the occurrence of 6 on the second die? No. So, in simply we can say that they are independent. Whatever is going to come on the first die is not getting affected by whatever is going to come on the second die. Right? Now in such cases what happens, the probability is P of A into P of B. Now let us consider the example that I gave you. You are getting 6 on the first, you are getting 6 on the second. Now if I ask you what is, or I can say what is the probability of getting 6 on both the die. So when you have your sample space, you would get 6,6, and that will be 1 by 36 actually. Now how do you get actually from that? So P of A is getting 6 on the first die, which is this, into getting 6 on the second die, again 1 by 6. So you see eventually you get 1 by 36. Okay. So the theorem that we have in independent events is, if A and B are independent events associated with the random experiment, then probability of A intersection B is probability of A into probability of B. Okay. Now let us proceed with problems. So the first question that we have over here is, events A and B are such that probability of A is given, probability of B is also given to us, and again they have given in the verbal form, we have to convert it to theoretical form. So it is given probability of not A or not B. Now we have to state whether they are independent or not. Whenever they are independent, this should be satisfied. So this is a necessary condition for any two events to be independent. So what we are doing, we are converting this first to the theoretical form. Not A is A bar, or means union, not B is B bar. That means this is what we have. Okay. Now see what we are doing. Now I am applying De Morgan's law, and what are we getting over here? P of A intersection B whole bar. Now P of A intersection B whole bar can be written as 1 minus P of A intersection bar. We have seen this in our previous session. Now from here I will get P of A intersection B, that is 3 by 4. Now I will find product of A, product of P of A and product of P of B, that is 7 by 27, which is not equal to P of A intersection B. That means A and B are not independent events. So over here you don't even know what random experiment you are carrying out and what is this event A and B means. They have just given us the probability, and just with the probability we can come to a conclusion whether they are independent or not. Okay. So over here they are not independent events. Now this can come again as in 2-mark question. It cannot come as MCQ because it's a state whether A and B are independent events. So either it's true or false or not sufficient information. Only 3 options are there, we need 4. So it can come most probably as a 2-mark question. Next question. A and B are two candidates seeking admission in a college. Now the event is, A is getting admission in the college, B is another person getting admission in the college. The probability that A is selected is 0.7, which is like 70%. And the probability that exactly one of them is selected is 0.6%. So that's high because it's above 0.5. That means one of them gets selected, there is a high chance, exactly one of them. Find the probability that B is selected. Now let's see. So E, let E be the event, candidate A is selected, F be the event, let candidate B be selected. So P of A, probability of getting A admitted is this. Now what I'm trying to do is I need to find f of a, basic p of f, right? Probability of getting B selected. So how I am proceeding is, first of all I am converting this sentence. Probability that exactly one of them means what? E but not F, or not E but F. So here only E is getting selected, here only F is getting selected. Or means any one of them can happen. So what we are doing is, now or we always written as plus sign. That's what we did. Now intersection of E and F bar, they are independent events. E and F bar. Okay. Him getting selected or him getting selected, they both are independent. So that's why I am multiplying both of them, because they are in intersection. Similarly here as well. Now I am applying the theorem P of F bar is 1 minus P of F. Here P of E bar is 1 minus P of E. Now you can just apply distributive property and this is what you will get eventually. P of E you already know. Here also P of E you already know. This is what you will get. And when you solve it, you will get P of F as 1 by 4. Alright. So this is the probability of B getting selected. Now since this is given in decimal, you can convert it to decimal. You will get 0.25. Okay. And also one confusion that students face is, they will ask P of E is 0.7, then P of F should be 0.3. That's only possible when both of them are mutually exclusive and exhaustive event. Otherwise it's not possible. So that's why this is 0.25, but when you add both of them, you won't get to 1. Right? Because other elements are also there. Getting one of them selected, getting both of them selected. You can go to the previous session and then you will come to know when the sum is going to be 1. Okay. Next question. Probability of solving a specific problem independently by A and B are half and 1/3. That means independently. So A solving it is half, B solving is it 1/3. Now if both of them try to solve the problem independently, find the probability that the problem is solved. Now when a problem is solved, let's say 2 people are there, I want the problem to be getting solved. So if any one of them also solved, it is solved, or both of them also solves, it's solved. I need minimum one, right? At least one of them should solve. So that's why it is going to be union. At least one of them, E or F. So now you can apply directly the formula. So here you can see how are you actually getting. So this thing, how can I write this thing? I can be written as 1 minus P of E intersection F whole bar. Right? No. It is 1 minus P of E union F the whole bar, right? Now here I am applying De Morgan's law, so it will be here from here. So P of E intersection F the whole bar can be written as, again, P of E bar union, intersection. I'll just write it over here. 1 second. Yeah. So this is written as 1 minus P of E union F whole bar, applying the law. Now this can again be split as P of E bar intersection F bar, which is 1 minus P of E bar into P of F bar. They are independent. They do not depend on one another. Him solving the problem does not anyhow depend on other person solving the problem. Okay, and thereby I am just multiplying both of them. P of E bar is 1 minus P of E, P of F bar is 1 minus F, P of F, and you get this. So problem getting solved is basically any one of them is solving, at least one of them is solving. So this thing is basically means at least one of them solving. And since only 2 are there, so it will be E union F. Next is exactly one of them is solving. Both cannot solve together. So how it will go? E is not solving, F is solving. F is solving but F is not solving. right? And then what we did, so when you simplify this, so I will be doing over here, so it will be P of E bar into P of F plus P of F, sorry, P of E into P of F bar, and then again you open P of E bar, P of F bar, and then when you simplify, this is what you will be getting. You can look over here, the same thing is being done. What are you getting eventually, right? They both are exactly the same. So when you simplify, you will get this. Now you can just substitute, so it's half. So there is 50% chance that exactly one of them will solve. Next problem, A and B throw alternatively a pair of die. This is a very important problem. Similar to this, many problems can be made. It's like winning and losing, but with alternate chances. Now what is happening, A and B are playing a game. Now how the game keeps on going is, if A wins, when does A win? When he gets 6 before B. So let's say if A is starting the game, if A gets 6 first, then he won. But if A didn't get 6, then again B will throw. Okay, right? And just keep this in mind. Getting 6 basically means what? You are throwing a pair of die. That means the sum should come as 6. Okay, for example, A is rolling 2 die, a pair of die. He got 1 and 6, sorry, 1 and 5, then he won. But if he didn't get 2 numbers whose sum is 6, then B will throw. When B will throw, if he gets 7, then he won. Or else again you will get, A will get a chance to roll the die again. Okay, this is how the game proceeds. Right? Now what is given is, find their respective chance of winning the game if A begins. When A begins the game, what are the chances that B will win or A will win? Let's see. First of all, let us find the probability for both. Getting a 6 is what? 5 by 36. Why? Because there are 5 chances. So if you want, we can list this down, right? So you have 1 5, then 2 4, then 3 3. What else do we have? Then the next one could be 4 2, and then 5 1. Right? We have total 5 ways that 6 will come. So it's 5 by 36. And not getting 6 is what? 31 by 36. That means A not winning, not getting 6. Getting 7, you have 6 chances. You can try some similar way. Not getting 7 is, they both are complementary, this and this. So you will just get by subtracting this 1 by 6 from 1. So you will get 5 by 6. So I am just writing everything in the term. So let us say this is E. So this is E bar. This is F. So this is F bar. Okay. Now let's say A starts. Now we have to understand in what all the chances A will win. So it could be first because he is starting. So there is a chance he will win in the first rolling itself. Then when can he win? He can only win when in the second chance B misses. B won't get 6. B won't get 7. Then again he will get a chance third. Now there is a chance for him to win. So third. Then again fourth chance will go to B. Now again A will win only when B won't get 7 in the fourth trial. Then the fifth chance again A will get. So getting 6 in the first throw is 5 by 36. Getting 6 in the third throw. Now you have to understand all are independent. That means what? Getting third, when A will get 6 in the third row, that means in the first time A didn't get. But in the second time B didn't get. So this is for the first chance. A, which A rolls. Not getting is 31 by 36. B also not getting is 5 by 6. Now A is getting 6. So it's 5 by 36. Similarly, you have to do for getting 6 in fifth throw. So this is how it will look like. Here he is winning in the first. Here E is winning in the third. Here A is winning in the fifth trial. Okay. So how are we doing? All are independent, that's why you're individually multiplying. Now when you see, you will understand it's forming an GP, right? So this is your A, and then you keeps on multiplying this term again and again. See r square, then it will keep on going, r cube and all, and it's an infinite series because the game can keep on going. So we know that sum of a GP, infinite GP, is A by 1 by r, 1 minus r. Given that mod r is less than 1, we can very well see here mod r is less than 1. This is your r. So it will be A by 1 minus r. So when you simplify, you will get 30 by 61. So this is probability of A winning. In that case, probability of B winning is this. Now these two probability is only true when A starts the game. If B starts the game, it is going to be different. But the process remains the same. I hope all the questions that we did in today's class is clear to you. If you have any doubt, you can put your doubts in the comment section. Please like, share and subscribe.